Could there be a mirror universe made of dark matter? Now, I know what you're thinking, and don't go there, because we never need to go there, unless it's the Michelle Yeoh mirror universe, because that's the only one I'm ever going to accept. Dark matter is the name that we give to mass that we cannot see or interact with. You see, we know that there's something out there affecting our universe. We can see its influence on the path of light, on the motion of stars, on galaxies. So we know that it's related to gravity in some way, which implies that it has to have mass. Now, since we can't see it or interact with it, we just refer to it as being dark. There's a few ideas out there on what it could be made of, and scientists are working on building tools that might help us interact with it and measure it if we can just determine which one it is. Now, this paper that was put on the archive and has been picked up by a number of science magazines suggests that there could be some form of symmetry between normal and dark matter in the universe, leading to both existing. But the key difference would be in the mass of the particles that make up the atoms. You see, the atomic nucleus of all elements are formed from different combinations of protons and neutrons. Now, these particles have nearly identical mass, and this causes the atoms to be stable. If they're free from the atoms, neutrons have a lifetime of about 15 minutes before they decay into other particles. This is called beta decay. Now, I have a video on that. If you want to understand more, I'll put it in the caption. But protons, you see, protons are so stable that current calculations say its lifetime is longer than the current age of the universe. The lower limit on how long a proton would live for is 10 to the 36 years. So as far as we know, a proton has never yet decayed into other particles. But if the mass of a proton were slightly different, just a little bit heavier, it would become unstable, similar to a free neutron, and it would decay in a few minutes. Now, this would change the entire stability of our universe. The dark mirror universe proposes that dark neutrons are a little bit lighter, and so they're stable, while dark protons are a little bit heavier, and so are unstable. In the paper, they limited the parameter space to only looking at a case where the dark protons decay before they can form atoms, leading to a soup of dark subatomic particles, mostly made up of dark neutrons, that never bind to form larger structures. Now, if they looked at a more complicated option where dark protons are stabilized within dark nuclei, then this would lead to questions and considerations around dark Big Bang nucleosynthesis. This refers to when the nuclei of atoms, other than hydrogen, were formed in the first moments of the Big Bang, so creating things like helium and deuterium. This is just an idea. The paper itself hasn't been peer-reviewed yet, but it's been picked up by a lot of science magazines and accounts already, and they're kind of purporting this whole dark mirror universe thing. Now, I've not read the entire 26-page paper in detail. It's all a lot of high-energy physics in the context of cosmology, so it's very detailed. But what I can say is that all these news items are taking one small part of what the paper is saying, and they're running with it. Like I said, they specify very clearly that they ran models in a relatively simple and safe region of parameter space, making an assumption about the stability of dark protons and neutrons and setting the model up so that dark atoms cannot be easily formed. It's a potential model that can help explain what form dark matter might take. There probably isn't a mirror universe with dark planets forming around dark suns and dark humans watching us trying to figure out what the hell we're doing. Probably.